Hello, this is NRK Academy, and we have our series of IIT NEET, Crack IIT NEET. And we have Kinematics 2. We have already seen in Kinematics 1 the concepts of distance, displacement, one-dimensional, two-dimensional, and three-dimensional motion concepts. And we have also seen the graphs, uniform motion in a straight line. And we have seen average velocity, instantaneous velocity. And we have got a clear understanding of that. That is Kinematics 1. So you can go to Kinematics 1 if you have not seen it, and then come here, Kinematics 2. Now, Kinematics 2, we will be doing acceleration. ACCELERATION, acceleration. Like we have in bikes, we accelerate, which means we change the velocity. As simple as that. Acceleration means change in velocity. So suppose you are going on a road, obviously you are always accelerating. Sometimes you're going faster, sometimes you're going slower. Even slower is called acceleration, it's called retardation. So suppose you go going in a bike and you are at, you see your speedometer, it's at 20, next let's say after 1 second it's 21, next second it's 25, then you stop 0, then you went ahead, like that. Time is changing, velocity is changing. That is acceleration. But we have a concept called uniform acceleration. Uniform actually means constant. Uniform means constant. How can acceleration be constant? Yes, it can be, because acceleration is not velocity. Acceleration is change in velocity. So acceleration may be constant. Yes, the simple concept is change in velocity is constant. It's a very simple concept. Rate of change in velocity is constant. So suppose you started with 0, after 1 second, constantly increasing, you reached let's say 10 meters per second, instantaneous velocity after 1 second, then again constantly increasing slowly, and in the second you reach 20. You understand? So you started with velocity is equal to 0. Then after 1 second, velocity became, at that point became, let's say 10. After 2 seconds, velocity became 20. After 3 seconds, velocity became 30, and so on. So what's happening here? Observe. In the t is equal to 1, t is equal to 0, t is equal to 0, you have velocity is 0. T is equal to 1, at that point, t is equal to 1, instantaneous velocity, 1 second, you have 10. Then t is equal to 2, you have 20. And so on. T is equal to 3, you have 30. And so on. So what's happening here? In every second, the velocity is constantly, even between 0 and 1 second, it will be constantly increasing. That's where the concept of uniform acceleration comes in, and that's where the calculus concept comes in, because every moment, not every second, it's increasing uniformly. So it is like a parabola. The graph will come as a parabola. If you plot this and give a smooth graph, not straight line meeting, but smoothly if you meet, you will find that at every moment is increasing constantly, at every moment. That's where graphs and calculus comes in, which you'll see later. So for now, we have understood clearly. V is equal to 0, t is equal to 0, v is equal to 1, 10, t is equal to 1. At t is equal to 2, v is 20. At t is equal to 3, v is 30. This is one example. So what is the change? It is 10. So acceleration, which is given the symbol of A, is 10 meters per second. Why? Change in velocity. 10 meters per second is change in velocity, and change in velocity per second. So 10 meters per second is a change in velocity in 1 second. Is it clear? So I hope it's very clear. So now what are the equations? So before we start with the equations, what are the variables? We have initial velocity u, we have final velocity v, we have acceleration a, we have displacement, not distance, displacement s, and we have time t. So how do we derive the equations? First, let me state the equation. V is equal to u plus at is the first equation. S is equal to ut plus half at square is the second equation. V square minus u square is equal to 2as is the third equation. So how do you derive it? First derivation is very simple. It is coming from the definition only. Acceleration is change in velocity in 1 second. So what is the change in velocity? V minus u in 1 second divided by t. So if you change it, if you rearrange it, v is equal to u plus at. It's as simple as that. Now, how do you derive s is equal to ut plus half at square? We'll do that now. Now, if the velocity is changing uniformly, then u plus v by 2, average velocity can be stated as u plus v by 2, isn't it? Isn't it? By common sense, by intuition, initial velocity is u, final velocity is v, and it's changing uniformly. So what will the average velocity be? It will be an average of that. So average velocity we know is s by t. So you have u plus v by 2 is equal to s by t. Then you cross multiply, ut plus vt is equal to 2s. Ut plus, here for v we substitute u plus at from the earlier equation, is equal to 2s. ut plus bracket u plus at into t is equal to 2s. ut plus at square is equal to 2s. Dividing by 2, s is equal to ut plus half at square. So suppose u is 0, initial velocity is 0, it will be like an equation of a parabola. Any parabola is y is equal to some constant into x square. S is y, one variable, t is another variable, half a is constant. So this is the equation of a parabola. You will see it in the graph. Now with the first two equations you can do on your own, we can get v square minus u square is equal to 2as. So if you notice, in the first equation, v is equal to u plus at, we don't have s. In the second equation, s is equal to ut plus half at square, we don't have v. In the third equation, v square minus u square is equal to 2as, we don't have t. So we use these three fundamental equations of what? Of uniform acceleration, not acceleration. The acceleration has to be uniform. So now the graphs are clear. Displacement time graph, as we already told, is a parabola. Velocity time graph is a slanted straight line. So that completes the beautiful concepts. When you learn through concepts, suddenly everything becomes so simple and so clear and so subtle and deep. Okay, simple but deep. Thank you so much. We will meet again in Kinematics 3, where we deal with freely falling bodies or thrown upwards, which means bodies under the influence of gravity. Motion under gravity is Kinematics 3. Thank you.